In this video, we're learning how to find all 6 trig values given a point on the terminal side of an angle. So let's jump into example 1. So example 1 says the point 3, 4 is on the terminal side of an angle in standard position. Determine the exact values of the 6 trigonometric functions of the angle. So what we're going to start by doing is actually sketching this point and this angle. So we know the point 3, 4 is on the terminal side, and I'll explain what that means in a second. First, we're just going to plot the point 3, 4. So 3, 4 is right here, and now what we're going to do is we are going to draw a line like this to this point. So this line that I drew, and let me actually put it in a different color. So this yellow line is the terminal side of our angle. That's what they're saying. And standard position means that our angle is going to start at the positive x-axis. So it's going to start here. So our angle is like this. So I'm just going to label this angle as theta. So that's what they mean by the terminal side of an angle has the point 3, 4 on it, and it's in standard position. So you're going to start from the positive x-axis, you're going to go counterclockwise, and you're going to draw a line from your origin to that point, and that's going to be the ending side of your angle. So now what we want to do is find the 6 trig values of this angle. So what we're going to do is we are going to create a right triangle. I'm going to draw a line like this, and like this. And we always want to create a right triangle with our x-axis, not our y-axis. And we know from our point that this blue line is 3 because the x-coordinate is 3, so it's 3 units over. And since our y-coordinate is 4, we know that this pink line is 4. And now what we want to do is find the yellow line because we're going to need it to find some of our trig values. So we're going to use the Pythagorean theorem. So we know that the Pythagorean theorem is a squared plus b squared is equal to c squared, and we're just going to plug in what we know. So in this case, we'll say a squared is 3 squared, and then we have to add that to our other leg squared, so 4 squared is equal to our hypotenuse squared. We'll just leave it as c squared. And now we're just going to simplify this. So 3 squared is 9, plus 4 squared is 16. This is equal to c squared. We're going to add 9 plus 16 to get 25 is equal to c squared. And finally, take the square root of both sides of our equation to get that our c value is 5. So this yellow side is 5. And now that we have all 3 sides of our triangle, it's very easy to find the 6 trig values. So first I'm going to write SOHCAHTOA, just so we remember the 3 main trig ratios. And let's actually find sine, cosine, and tangent first, and then I'll show you guys how to easily find the other 3, cosecant, secant, and cotangent. So sine of theta is equal to the opposite side over the hypotenuse. In this case, our opposite side is 4 because it's across from our angle. So we have 4 over our hypotenuse of 5. So the sine of our angle is equal to 4 over 5. We're going to do a similar thing for cosine. So cosine of theta, so it's a and h, so it's adjacent over hypotenuse. In this case, the side measuring 3 is our adjacent side. This is going to be over our hypotenuse of 5. So the cosine of our angle is 3 over 5. And now we're going to do the tangent. So tangent is TOA, so it's opposite over adjacent. So opposite is 4. Adjacent is this blue side measuring 3. So we get that the tangent of our angle is 4 over 3. And now we're going to find the cosecant, secant, and cotangent of our angle. And the nice thing is that these 3 are just reciprocals of the first 3. So cosecant is the reciprocal of sine. So we're just going to flip sine upside down. So we're going to get 5 over 4. Secant is the reciprocal of cosine. So we're just going to flip cosine upside down. We're going to get that the secant of theta is 5 over 3. And cotangent is the reciprocal of tangent, so we're going to flip our tangent upside down. We're going to get 3 over 4 as the cotangent of our angle. And now we're finished because we found all 6 trig values. Let's go through 2 more examples. So this next example is similar. We have the point 2, -5 on the terminal side of our angle, and we want to find all 6 trig values. So we're going to start by sketching this point. So we have 2, comma negative 5 this time. Let's extend this a little bit. So 2 comma negative 5 will be right here. We're going to draw in a line like this. So this time our angle in standard position is this angle over here. But in order to find our trig values, we're actually going to draw a triangle in the fourth quadrant. So I'll show you guys what I mean. So we are going to draw a right triangle with the x-axis. We are always going to draw a right triangle with the x-axis. And when we are actually solving for our trig values, we're going to be using this angle right here, this green one, to set up our trig ratios. So what we want to do now is fill in the sides that we know. So this point down here is 2 comma negative 5. Which means that this blue side is positive 2 because we went 2 to the right on the x-axis. And this pink side, we went down 5, so we're going to write it in as negative 5. So it's important to actually put the signs correctly, or else you will end up messing up some of your trig values. And now let's find this yellow side. So we're going to do the Pythagorean theorem. So we're going to say that 2 squared plus negative 5 squared is equal to c squared. 2 squared is 4. 5 squared is 25. This is equal to c squared. And 4 plus 25 is 29. Square root both sides to get that c is equal to the square root of 29. And we are just going to leave that as is. So I'll just put an arrow. And our hypotenuse is always going to be positive. So your legs can be positive or negative, but the hypotenuse will always be positive. So now what we're going to do is just find the 6 trig values. So let's start by writing SOHCAHTOA. So sine of theta is OH from SOHCAHTOA. So we know it's going to be equal to the opposite side, which is negative 5. Because that's opposite of that green angle over hypotenuse of the square root of 29. And we don't like to have roots in the denominator of our fraction. So we're going to multiply the top and bottom of our fraction by the square root of 29 to get rid of that. On the top, we have negative 5 times the square root of 29. On the bottom, the square root of 29 times itself just leaves us with a 29. So the sine of our angle is negative 5 root 29 over 29. Similar thing for cosine. So cosine is AH. So we know that it's adjacent, which is 2, over our hypotenuse of the square root of 29. And now again, we need to multiply the top and bottom by the square root of 29. On the top, we get 2 root 29. On the bottom, we are left with 29. Moving on to the tangent of theta. Tangent is OH, so it's opposite over adjacent. So our opposite side is negative 5, and our adjacent side is positive 2. So we get negative 5 over 2. We don't have to simplify that at all. And now we are going to do the cosecant, the secant, and the cotangent. So when we're doing the cosecant and the secant, we're actually going to look at that first unsimplified version of our sine and cosine. So we're going to look at this one right here, and we are going to flip that upside down. Then we won't have to rationalize the denominator again. So when we flip that upside down, we're going to get the square root of, oops, let's put that in yellow, the square root of 29 over negative 5. We don't have to simplify because our square root's in the denominator. If we do the same thing for the cosine, so we're going to flip this one upside down, we're going to get the square root of 29 over positive 2. And now for cotangent, we're just going to flip tangent upside down, so we will get 2 over negative 5. So we're finished with this problem because we found all 6 trig values. Let's go through one more just to make sure we really understand this. So for this last example, I encourage you guys to pause the video and try it on your own, and then you can watch me work through it to make sure you've done it correctly. So we're going to start by plotting our point that they gave us, which this time is negative 6, comma negative 2. So 1, 2, 3, 4, 5, 6, 1, 2. So right here, let's mark this negative 6, negative 2. We're going to draw a line from the origin, and now we are going to draw in our different sides. So we'll draw our opposite side and our adjacent side. So remember, the triangle always has to be made with the x-axis. So this is our entire angle theta. but when we're finding our 6 trig values, we're going to use this little green angle in this triangle right here. So now let's fill in the sides we know. So we know this pink side is -2 because that's our y-coordinate, and we know the blue side is -6 because that's our x-coordinate. And now we're going to find the hypotenuse by using the Pythagorean theorem. So we're going to say -2 squared plus -6 squared is equal to c squared. -2 squared is 4. -6 squared is 36. This is equal to c squared. And 4 plus 36 is 40. So we get 40 is equal to c squared. Let's take the square root of both sides to get rid of the squared on the right side. So we get the square root of 40 is equal to c. And now we just want to simplify the square root of 40. So the square root of 40 is the same as the square root of 4 times the square root of 10. And the square root of 4 is 2. So we get that c is 2 root 10. So let's write that here. Whoops. So 2 root 10. And now let's go ahead and find our 6 trig values. So let's write SOHCAHTOA. And we will start with the sine of theta. And remember, we're looking at this little green angle. So we want opposite over hypotenuse. So our opposite is -2. Our hypotenuse is 2 times the square root of 10. And we're going to have to rationalize this denominator. So we're going to multiply the top and bottom of our fraction by the square root of 10. On the top, we have -2 root 10. And on the bottom, we have 2 times the square root of 10 times the square root of 10. When you multiply the square root of 10 by itself, it becomes 10. So we have 2 times 10, which is 20. And now we're just going to simplify this. So -2 over 20 is going to leave us with a -1 on the top. So we'll just leave it as a negative. And then on the bottom, we are going to have a 10. I'm going to leave some space underneath to do cosecant. So now let's do the cosine, which is AH, so adjacent over hypotenuse. So we have -6 over our hypotenuse of 2 times the square root of 10. Again, we need to rationalize the denominator. Multiply the top and bottom by the square root of 10. On the top, we have -6 times the square root of 10. On the bottom, 2 root 10 times root 10, again, is going to give us 20. And we're just going to simplify this. We're going to divide -6 and 20 both by 2. So we get -3 root 10 over 10 as our cosine. And now let's just do the tangent. Tangent is OH, so it's opposite over adjacent. Opposite is -2. Adjacent is -6. And we're just going to simplify this. We have 2 negatives, so it's really positive 2 over 6, which simplifies to positive 1 over 3. And now we are going to use these, just find the reciprocals to find the other 3 trig values. So cosecant of theta, we're going to use the reciprocal of that first sine one, so the -2 over 2 root 10. We're going to flip it upside down. We're going to get 2 root 10 over -2. And we just want to simplify. 2 over -2 is just -1. So we get negative square root of 10. Now we're going to do the secant of theta right here. We're going to flip -6 over 2 root 10. We're going to flip that upside down, find the reciprocal. So we get 2 root 10 over -6. And we want to simplify this. So we're going to divide 2 and -6 by 2. So on the top, we're just left with the square root of 10. On the bottom, we're left with -3. And now finally, the cotangent of theta. Let's just flip 1/3 upside down because that's easy and it doesn't have any roots. So if we flip 1/3 upside down, we get 3 over 1, which is just equal to 3. So this is how you guys find all 6 trig values given a point on the terminal side of your angle. If you guys want some more practice with problems similar to these, check out the link in our description for a free practice worksheet.